Hey everybody, it's Mr. Brew from Infinity, the Math Institute, here with your next lesson. And this is actually lesson 2B, because lesson 2 is a little long. It covers integers, the coordinate plane, properties, and order of operations. And I didn't want to overwhelm you, so I split it up into 2 videos. But the progress we've made thus far has been terrific. I mean, whether we're talking about prime factorization, the coordinate plane, integer operations, these are the fundamental tools you're going to need to succeed moving forward. And instead of just getting through this stuff and knowing that you could pass this week's test, I'm not even giving you grades. I'm teaching you this because this is what's important for you to totally get a real grasp on. Because if you really, truly understand this stuff, it'll make the road to calculus and beyond so much easier than you could have ever imagined. So we're going to be reviewing a few things. I got a prime factorization, GCF, and LCM problem set aside for you. We'll also talk a little bit about the coordinate plane and the integer operations, which we talked about previously. And then this week we're going to get really into the properties of real numbers, which is good stuff, and the order of operations, and it's not what you think. So, you know, we're building up to great things. Let's get started with lesson 2B, and guess what's coming first? That's right, your squares and cubes quiz. All right, so let's get started with our squares and cubes test. You know how this goes, but just to review, I'm going to give you 5 seconds to answer each question. If I say 9 squared, it's not for you to think 9 times 9, 9, 18, 27, 36. No, this is so you have these completely memorized. It's like a knee-jerk reaction. When I say what's the first letter of your last name, you know it. You don't have to think about it. When I say 9 cubed, you have to know it. You can't be thinking about it. So let's get started. Number your paper from 1 through 10, and I'm going to get started right now. If you need to number your paper, pause the video and catch up. 6 cubed, 8 squared, 9 cubed, 13 squared, 8 cubed, 15 squared, 7 cubed, 14 squared, 10 cubed, 12 squared. Pencils down, and your answer should be 216, 64, 729, 169, 512, 225, 343, 196, 1000, and 144. And now we're going to do a vocabulary quiz in much the same way. You could try to write it down, or you could just mentally think about it, but what I want is precision. I want to know that you could recite the definition exactly as I do. So let's do 10 question quiz. Hopefully you know these as well as how I answer them. And if you don't, please make index cards, study up. These vocabulary words are essential. Prime number. A whole number greater than 1 whose only factors are 1 in itself. Integer. Whole numbers and their opposite. Subtraction. Adding the opposite. Reciprocal. 2 numbers whose product is 1. GCF. It's the greatest common factor, which is the biggest number that divides into 2 given numbers. Absolute value. Distance from 0. Graphing. Simply a visual representation of math. Polarity. That's just the positive or negative. If it's a positive or negative number. Batteries have polarity. The North and South Pole has polarity. Magnets have polarity. And of course, numbers have polarity. And then finally, division. Multiply by the reciprocal. We have one more. What does the identity do? We're going to find out today. I didn't tell you that one yet. All right, so maybe that was only 9 questions. Nonetheless, that's it for quiz time. Let's go over a couple of your homework problems. All right, everybody, so just a quick review. If this is your first time or your third time joining us, you know that we put all the links in the description below this video. This is part 2 of lesson 2. So if you've already downloaded or printed out the links from lesson 2A, the same links are there for lesson 2B. You don't have to, but if this is your first time joining us, you don't have to find lesson 2A to get the documents. They're also in this description. Anybody who has any questions or wants to give any feedback or whatever the case may be, email me at tutor@themathinstitute.com. Again, we need to have our multiplication done from 1 through 12, squares 1 through 15, cubes 1 through 10. Starting next week, we're going to up that. Vocabulary is essential. And now, a couple of weeks ago, we did prime factorization, and most specifically the GCF and the LCM. So why don't we take a look at a practice problem from your homework? One of the problems was find the GCF and LCM of 36 and 54. Well, I taught you my method. I learned it as the Dr. Shu method. You could think of it as the Mr. Brew method. Don't tell anybody I'm stealing his thunder. And we say, what's the lowest prime that divides both of these? 2, 18, and 27. 2 does not divide 18 and 27, but the next prime does, 3. 6 and 9. 3 also divides 6 and 9. 2 times and 3 times. Both of these numbers are relatively prime, meaning I can stop. And now, if you recall, we can see the GCF is simply this left-hand column. So the GCF is 2 times 3 squared, which is equal to 18. 18 is the biggest number that divides 36 and 54. The LCM is these same 3 numbers and the bottom row. Take a shortcut. We already know that this is 18. 2 times 3 is 6. So 18 times 6 is equal to 90 plus 18 is 108. The LCM is 108, meaning the smallest number that these 2 numbers divide into is 108. That was I mean, it's not that difficult, but one of the more difficult homework problems that you have. You should have no problem doing this, and you should start to be able to see the GCF and LCM with continued practice. Last week, we talked about ordered pairs. All right? First thing we have to do is be able to identify a location using an X and Y coordinate on a 2-dimensional plane. Well, there you go. So how do I locate point A? First, I look at the horizontal X value. It's positive 1, 2, 3. And then the Y value is negative 1. So A is equal to 3, negative 1. That's how we can give a real precise location using an ordered pair. B, this point is located on the X value of negative 3. And the up and down vertical Y value, it doesn't go up or down. It's on the X-axis. So the Y value would be 0. Again. Now, a quick recall. This is quadrant 1, 2, 3, and 4. And on your homework, you might have noticed they asked you to identify which quadrant a point on the axis is. It's not in a quadrant. It's not applicable. All right, the quadrants are inside the axes. Finally, if we're looking to plot the point 1, 3 and label it C, the X value is positive 1, and the Y value is positive 3. So boom, right there would be my C, point C. And point D is at negative 2 on the X-axis, negative 1 on the Y-axis. Negative 2, negative 1 is right here. That is point D. You should have no problem either reading the point or plotting the point. All right, And then finally, the last thing we talked about last week is integer operations. So let's take a look at that. First of all, subtraction is simply adding the opposite. And now the absolute value is the distance from 0. So the absolute value of -8 is 8 plus 3 is 11. Okay, just picked out some of the more difficult problems from your homework. -19 plus -7. When adding integers of the same polarity, I add and keep the polarity. 19 plus 7 is 26. I keep the negative polarity. All right, another subtraction problem. What is subtraction? Adding the opposite. 40 minus 8 is the same thing as 40 plus -8. When the signs are different and I'm adding, I subtract and keep the polarity of the greater absolute value. 40 minus 8 is 32. The absolute value of positive 40 is bigger than the absolute value of -8, so I keep the polarity of the positive 40. 14 times -7. All right, that's simply a multiplication problem, and if the signs are the same, it's positive. If the signs are different, it's negative. 14 times 7 is the same as 10 times 7 plus 4 times 7, which is 70 plus 28, which is 98. Is it positive and negative? Well, the signs are different, so it's negative. 14 divided by, -14 divided by -7. The signs are the same, therefore it's going to be positive. 14 divided by 7 is 2. And that's that. Now guys, I gave you a whole bunch of homework with integer operations. There's plenty of things if you just type in integer operations worksheet PDF in Google. It'll give you a whole bunch of them if you need extra practice. You need to be able to do these, like I told you, as a knee-jerk reaction. We can't be held up on the polarity when multiplying or adding or subtracting. We have to have this flawless, because as we get into the more difficult equations, having this down is essential to not making little mistakes that could lead to bigger mistakes. All right, so let's get started on some new material. Are you ready? All right, everybody, so I've been telling you how important all these essential foundational concepts are. This is where we really get started with the properties of real numbers. I'm going to teach you 12 of them all together, but they're really easy as long as you put in just a little bit of effort to memorize them and recognize them when you see them. So let's get started. I'm sure you've heard some of these before, but if not, it's all good. First things first, the commutative property. All right, anytime you hear commutative property, that simply means order doesn't matter. All right, an example of a commutative property would be A plus B equals B plus A. Please don't be uncomfortable that I'm using variables. These numbers, these letters just represent any number. In this case, any real number. So we can give you a specific example. Order doesn't matter in addition. 3 plus 2 equals 2 plus 3. Right? And we can plug in any number there. All right? It could be a fraction, it could be a decimal, it could be negative, positive, whatever. A plus B is the same as B plus A. We also have the commutative property of multiplication. And you'll never guess what that is. Can you tell me what it is? A times B is equal to B times A. Right? And another real life example, it could be anything. But let's just say it's -4 times 2 is equal to 2 times -4. Right? And any numbers could go in there. Any number times a number is equal to the reverse order. There you go. All right, that's grouping. That's order. Next would be grouping. And we call that the associative property. And again, we have it for addition, and we have it for multiplication. All right? And that's the same grouping, doesn't matter. Where's my green one? All right, it doesn't matter in what order or grouping that we do our multiplication. So, or addition. So A plus B plus C is equal to A plus B plus C. And in a real life example, you know, if we had 1 plus 2 plus 3, it doesn't matter if we add the 2 and the 3 first, or we add the 1 and the 2 first. Because 1 plus 5 equals 3 plus 3. It doesn't matter how I group them. And the same thing goes for multiplication. Multiplication, it would be A times BC equals AB times C. And we can use the same numbers. I'm not going to write them down, but you should. 1 times 2 times 3 can be grouped any way it wants. 2 times 3 is 6 times 1. And 1 times 2 is 2 times 3. And we notice 1 times 6 equals 2 times 3. It doesn't matter how we group them together. So that's the commutative and associative property. Commutative order, associative grouping. Finally, we have the distributive property. All right, and that simply states algebraically that A times the quantity of B plus C is equal to AB plus AC. All right, you simply distribute the A, and you do your lovely, lovely math humps. Check them out. Multiply A times B and add the product of A times C. All right, a real life example might be 2 times x plus 3. I distribute the 2 and I get 2x because 2 times x is 2x plus 2 times 3 is 6. Real life example of the distributive property. All right? Now, we got to talk about some important things and something that people don't truly understand. All right, first we have identities. All right? Identities are simply an operation that doesn't affect the value of the original number. All right? So we have an additive identity. And essentially what I'm asking you is A plus what is equal to A? You should be able to see, 0. A plus 0 equals A. Therefore, the additive identity is equal to 0. I can add 0 to any number and not change its value. Guess what's next? The multiplicative identity. And again, I'm essentially saying A times what is equal to A. And you see right off the bat, the multiplicative identity is 1. All right? So anything times 1 is equal to itself. Anything plus 0 is equal to itself. Then we get into the inverse. Very, very important concept. And the inverse, write this down, is how we get back to the identity. So when we're talking about the additive inverse, all right, we're simply saying A plus what is equal to the identity of 0. And this might be a little tougher than the identity properties, but you should see a plus negative a is equal to 0. 3 plus negative 3 is equal to 0. Negative 5 plus negative 5, or negative 5 plus 5 is equal to 0. The additive inverse is negative a. So what would be the multiplicative inverse? This is even tougher to see. Can anyone figure it out? First of all, what are we saying with the inverse? How do we get back to the identity, right? So a times what is equal to 1? This should ring a bell with your vocabulary. The reciprocal is two numbers whose product is 1. And you know the reciprocal, you won't say it out loud, but when you think reciprocal, you think flip, don't you? I know. I appreciate you not saying so in front of me. The reciprocal, a times its reciprocal is equal to 1. 1 over a is the multiplicative inverse. And you understand that this is the same thing as saying divided by a, right? A times 1 over a is equal to a divided by a, which is equal to 1. Got it? Very, very good. So those are the primary properties I need you to know, the first 9. There's a couple others that you're not going to need right away, but while you're taking notes and understanding properties, I'm going to tell you these 3 last properties really quick. Because they're properties that you may or may not have been using and you don't even understand why you can. The reason you can is because of these properties. The symmetric property. Simply states if A equals B, then B equals A. All right? Lots of times you're doing a whole algebraic equation and you come up with 7 equals x, but you just say x equals 7. You switch the sides. And you are allowed to do that thanks to the symmetric property. We have the transitive property. And that simply says, if A equals B and, notation for and, B equals C, then, that's a math notation for then, A equals C. This simply says that if I'm the same height as Bob, and Bob's the same height as Carl, then I'm the same height as Carl. We transfer that property as things are equal to each other. Finally, we have the reflexive property. And that simply states that A is equal to A. Now that might sound pretty silly, right? But I'll give you a quick example of how that works. If you have an angle, and you can say angle ABC is congruent to angle DBE. And why? Because of the reflexive property. They're the same angle. That's why they're congruent to each other. We could also do that with line segments when 2 polygons share a side. And I'm just giving you a little glimpse into the future where this is all going and why it's so imperative that you have a good understanding of these properties. But those are the 12 basic properties that are going to get you through everything. So please, memorize them, do your homework, see if you can recognize what property is being used where. All right? Now let's get on to order of operations. All right, everybody, so moving on to order of operations, all right? Just like I don't want to hear you say flip about the reciprocal, I never want to hear this acronym ever, because it's wrong and it's misleading. It doesn't help. We'll explain why, but more importantly, you'll be able to explain why very shortly. All right, the true order of operations is Gemma. All right, and now that stands for grouping symbol. All right, parentheses are not the only grouping symbol there is. We have brackets. We have vinculums, the line in a fraction. If we have a plus b over c, you don't divide before you add. This vinculum acts as a grouping symbol. There is no parenthesis yet. You still have to follow the grouping symbol. Same thing with the square root, a plus b. You would still add before you take the square root because this is a form of a grouping symbol. That's why I don't like parentheses or P. I like G for grouping symbol, which encompasses all grouping symbols. Exponents is next. All right, and one important thing to remember about exponents is it also includes roots. Roots are a form of an exponent. We'll get into that later. But just understand, grouping symbol, exponents, and roots. Then, the M is obviously for multiply. Now, what is division? It's multiplying by the reciprocal. It is a form of multiplication, which is why we don't need a D. You multiply and divide simultaneously from left to right. All right, you go from left to right and you do your multiplication and your division in the order that you see them. Finally, addition. All right, and that's the last one. Where is subtraction? Well, what is subtraction? Subtraction is adding the opposite. So it is a form of addition. We don't need a separate thing, and you don't add, then subtract. You add and subtract simultaneously from left to right. All right, it's very important. Very important. I mean, you always see these order of operations showing up on Facebook. How much more important can you get from answering the Facebook posts properly and showing off how smart you are? Well, don't worry, I got you back. Here at Infinity, you will no longer get any order of operation problems wrong because you have the proper method. So, let's start to review and talk about what your homework is going to be. All right, so that's about it for lesson number 2. You have a nice packet in your links, and I expect you to do all of your homework. Some things I want to mention about the homework is, number 1, I know there's 1 or 2 typos in the properties of real numbers portion. If you can figure out what was supposed to be there, great. If not, just skip that one question. Number 2, when you have these at the end, we're going to get into story problems or word problems. And I didn't talk much about them. It's just putting some of these new skills you learned to good use. What I want you to do is not only give me the answer, but I want you to create an expression or an equation that represents the question. If it was 5 degrees today and it's 8 degrees less tomorrow, what's the temperature tomorrow? Not only do I want you to answer that it's going to be -3 tomorrow, but I want you to set up an equation that says 5 plus -8, or 5 minus 8 equals 5 plus -8 equals -3. Being able to model equations and expressions given information is going to be really important. And if you have any problems, please send us an email. I'll let you know. I'll give you some hints, or say some comments underneath the video, and I'll address it during next week's lesson. So we went over everything from the coordinate plane, integer operations. This was lesson 1, prime factorization, GCF and LCM. Integer operations. And then we did properties of real numbers, which there's some practice sheets for you there. And order of operations, Gemma. All right, this is everything you need to know to do all of your homework. Please let me know what problems give you pause. And that way, those will be the problems we go over next week. Either way, thanks so much. I'm really glad you guys are joining me for this course. And it's great for everybody. I'm very excited. Visit our Facebook page If you haven't visited our YouTube or Instagram, themathinstitute.com, and any questions, just hit us up, tutor@themathinstitute.com. Happy math problems.